Hey, did you solve for the kilojoules yet? Dude, the answer was Abraham Lincoln Online. Don't ask me for help. Welcome to Curly Carbocation. Please subscribe and stay tuned. This will be my third video on logic checks. The first one was just explaining what a logic check was. My second one was on the ideal gas law, and here I'm going to talk about enthalpy. I still don't know what enthalpy is, truly. It's not heat, but it's kind of like it. You may be familiar with it like this. Q equals MCP delta T. Wait, doesn't it have an H? Yep, you're right. Delta H equals MCP delta T. So which one's the right one? I'm going with H because I'll show you why. This is the first law of thermodynamics. Delta H plus delta KE plus delta PE equals Q plus W. For those who take after Tolkien and require verbosity, this is the sum of the enthalpy with the kinetic energy with the potential energy altogether equals the sum of heat plus work in the system. Now, assuming that your system is not moving and not falling and there's no shafts to be worked on or nothing's producing work, it's actually just delta H equals Q. And delta H equals MCP delta T, which then also equals Q. Going back to geometry vocab, Q equals MCP delta T is the conditional statement. For all of you complaining about fundamentals, shut up or scroll away. While other videos will go over an example to show how the equation works, I show you how the equation works step by step. Let's say your task is to find the initial temperature. First things first, write down the equation. Whenever I'm tired and caffeinated, that delta sign's gonna throw me off, so I like to expand the deltas right away. Hey, point slope form, fancy bumping into you here. I'm first going to divide both sides by MCP, then subtracting T final from both sides. But that leaves you with a negative Ti. So now we've got to divide both sides by -1. And my younger algebra students will think of this by multiplying by -1. Now we're going to divide both sides by -1, but because this side has two terms, I'm going to say this side divided by -1 minus this side divided by -1. Delta H or HF minus HI over MCP divided by -1 plus that negative TF over -1. Now we're left with negative delta H over MCP plus TF equals TI. But to pretty it up even further, we can say TF minus delta H over MCP equals TI. Now that was a lot and we don't even have the units down yet. When you're adding and subtracting units, they have to be the same. Multiplying and dividing is a little loosey-goosey. So because we have this TF right here and it has to equal TI, we expect that this quotient has to equal a temperature value. So let's focus in on that. Enthalpy is a form of energy, so that will be joules. Mass has a unit of kilograms. CP is a constant like the R value. We have to actually search this one up. In this case, CP will have units of joules per kilogram Kelvin. Now this can get kind of wonky. There may be a part 2 to this.